to now, you have covered different aspects of statistics, different statistical methods, techniques for research, for data analytics. In this session, we will see how to use a very popular software for statistical data analysis, that is PSPP. In alternate or in substitute of IBM SPSS software, I think you might have heard about this software, IBM SPSS, very popular software for statistical sciences, for statistical methods, but it is a proprietary software under IBM. And very quickly, I am showing you its pricing. So you can see that around $1,500 per year. Okay, so you can see, and if you need some more features, then $4,000 per year. So we have to pay in lakhs to use this particular software every year. Okay, even academic plans are limited edition plans, and in which we are given very specific features. But if we want to work with data science, data engineering, data analytics, statistical analysis, we want to work with research based data evaluation, then rather than using such proprietary software that is very, very costly, we can go for its substitute, that is PSPP. Okay, it is having so many features, and most of the statistical methods and techniques are integrated in this software. So it is product of GNU, okay, GNU PSPP, and completely free and open source. And as far as its performance is concerned, you can see that more than 1 billion cases can be integrated. More than 1 billion cases means if you have a big data, if you have a huge data file, okay, if you have any particular Excel sheet or some particular data set in which millions of records are there, so without any worry, we can use this particular software. So support of more than 1 billion variables. Okay, however, in general, we do not use 1 billion variables, but it is providing that much feature also. Generally, we take 4 to 5 parameters, 6 to 7 parameters, whatever scale you are using, whether you are going for Likert scale or any type of questionnaire. So generally, we do not have 1 billion variables. Still, it is giving us features to use more than 1 billion variables, and no license fee, no expiration date. Okay, no expiry date, no license fee, and without any issue of proprietary software, without any issue of any plagiarism or some pirated software, we can use it. Interoperability, we can migrate the results to MS Word, we can migrate results to HTML and different other products. Okay, it is completely free, and as far as its features are concerned, most of the techniques are already available. Completely GUI based software, graphical user interface based, whatever tool we want to implement, and it will give you look and feel of SPSS software. If you have already gone through that software SPSS, then you might have seen such type of interface. Okay, so each and everything is available, and one more benefit is there. Even if you are already working in IBM SPSS, you can export or you can transform your files for PSPP. Interoperability, whatever files we are creating in SPSS, those we can open in PSPP and vice versa. Okay, so if we want to translate, if we want to transform results in PDF format, open office format, or ASCII format, it can be done. Data visualization, different types of visualization features available. I will show you some of these features in live demonstration mode. I will take some data set, and with those I will show you some demonstrations. But before covering any practical demonstration, we are going through its features. So these are different features, multiple methods available for statistics, missing value functions, because in data science, in research methodology, missing value imputation or missing value treatment is very, very important. Many times when we collect primary data or secondary data, then some records, some particular fields may be empty. So how to use those empty records without deleting a particular row or record? Statistical functions are available, whether you are going for descriptive statistics, inferential statistics, or multi-dimensional statistical analysis. In different ways you will be able to use it. We can export our results to HTML format, PDF format, or in multiple other formats. So you can simply download it. Okay, it is completely free and open source. GNU.org software PSPP, and its variants are available for Windows, Mac, Linux. For different operating systems, you will be able to use it. Cross platform, free and open source, and fully extensible. Okay, is this, am I audible and is this visible to all of you? Kindly confirm in chat window again, so that we'll come to know that all of you are
Yeah,
getting.
Gaurav, audible and visible. No issue.
Okay. Now, dear participants, this software I have already downloaded and installed in my system. So I'm opening this software. Okay, so I'm opening this software. So simply after downloading and installing, you can work with this product that is available in free distribution. Okay, and there is single distribution, there is single license of PSPP software which can be used by all, whether you are from corporate world or you are from academics. Okay, so this one is the interface working panel of PSPP software. Very quickly I will show you its different features, different options, and after that we will go for some very basic data analysis. I will take some applications, I will take some data related to different domains, and then we will see. Okay, so different types of evaluations we can perform. So this one is dashboard or data editor, and this interface is very much similar to SPSS software. In SPSS also we are having this type of interface where we have to define our data. So if I want to work with data evaluation, if I want to work with research based data analytics, then how to go for it? By which way we have to proceed in SPSS software? Okay. So you can see at bottom left we have two options. One is data view and second is variable view. Okay, on click of data view we can enter data. On click of variable view we have to specify the variables. Okay, one point we should be very much clear that to analyze any data, first of all we have to define it. Def- and when we go for data definition, data declaration, it comes under a specific technical term that is known as schema. Okay, so first of all we have to define schema. For example, just for an example, I want to take a particular data set of students, and first attribute I want to take as age. So age, and which what is the type of age? So I have to define its data type, whether it is numeric or string or anything else. So you can see that simply on double click of numeric it will show what is the type of this particular data, numeric, comma, scientific notation. For example, I'm using some exponents, we are using some scientific notation, pi or something else. If we are taking date of birth, then we will take date of which type. For example, we are taking date of birth, date of inception, date of end date, start date. So we can use that particular format, all formats, all international date formats available, we can select. String, if we are taking only name, for example, name, city, okay, in that, or gender, or some particular state, country, for that we can take string. String means we are taking a particular sequence of characters, okay. But age, obviously we have to take in numeric and no decimal. Without any decimal we want to take, and 3 digits, okay. Now age variable we have defined, no decimal, and which level we want to specify, missing value none. If we have specified missing value none, in that case this particular record, all values should be complete, okay. So, and what about different other parameters? So majorly, whether we are using SPSS or PSPP, we have to define the measure, okay, measure or measure, whatever you want to pronounce. Type of data, these are three types of data, whether it is nominal, ordinal, or scale, okay. In SPSS also we have to define our data, structure of data. Nominal data type is associated to that variable or attribute which is not having a particular inherent value. I'm repeating this point, which is not having any inherent value. For example, somebody's name. Name is not having any value. Okay, X, Y, Z. It is not having any specific characteristics. For example, city name, state. It is not having any particular characteristic. Okay, in that case we use nominal. If I want to use some particular uh, value based parameter, value based parameter means for example ranking. In case of ranking we can use ordinal. In case of some, for example, somebody's height, somebody's some particular parameter which is having some inherent value, some characteristics, okay, because height, weight, width, these are having some particular some specific weight, some specific value. So in that case we use ordinal. For example, rather than age we are using here Aadhaar card, okay. So Aadhaar card is not having any particular characteristics. If I am taking PAN card is not having any characteristics. It is only for identity. It is only for identity. Aadhaar card is only for identity. In that case, we should use a nominal. If you will take Aadhaar card in scale or ordinal, scale means any free value you can put. Free value means weight, marks, your uh, rank, height, or for example, we are going for medical data analysis, blood pressure. Blood pressure we can put in scale because that is having a particular value. BP level, sugar level, diabetic level. Okay, but somebody's name, somebody's Aadhaar card, PAN card, these we put in nominal. Okay, so obviously age is having a particular value, so we can put it in scale. Is this clear to all of you? Are you getting this point? Kindly confirm. Okay. Generally, we use scaling scale parameter. Okay, age and marks, numeric and decimal. You can put it in unknown also. Okay, otherwise we can put it in scale. Is this clear to all of you? Are you getting this content properly?
Yes, sir.
So age marks. Now some other parameter, for example, I want to put pan. Okay, pan should be in string. Okay, and obviously its measure should be in nominal, because pan is not associated with any characteristic. We are not using it as independent variable, because depending upon somebody's pan, anything cannot be predicted. Okay, if we want to say that, okay, if this is if pan is independent variable and somebody's bp level, so there is no relationship between pan and bp level. There is no relationship between somebody's Aadhaar number and somebody's survival, until and unless we are taking numerology or astrology in consideration. If we are taking numerology and astrology in consideration, in that case you can take Aadhaar card as independent variable. But in general, for scientific applications, we do not take it. Okay. So three we have taken. You can delete it. If I want to delete anything, simply right click and clear variables. Now two variables we have declared of type numeric. Label, if you want to put a label age marks. Okay, alignment, you can put at which particular alignment you want to put. Okay, and variable view. Now you can see that whatever variables we have declared in variable view, we are provided age those particular variables to enter the data. Now we can put the data. Okay, for example, this one is the data. Okay, now we are specifying, we are entering data. If you want to take data, for example, from Excel sheet, you can import data from Excel sheet also. Okay, so just randomly I'm creating some data, and now you can see copy paste. Simply select data, copy data from MS Excel and paste here. So those are, so what I have done, I have simply copied data from Excel sheet and pasted here. Now this one is variable view, this is data view. Okay. Now different operations, different mathematical operations, if we want to perform, which type of mathematical operations we can perform, which type of transformations or evaluations we are able to perform. So you can see file menu, we can open data, edit. Now we will start from data. Okay, data menu. Okay, you can on or off grid view. So you can see this one is grid view. Value labels, value labels. So you can see if I disable grid view, it will be in this format, but obviously it will be better to integrate. Now this particular data is available, I want to sort it. Sort cases, sort by age or sort by marks. You can see simply we will click on this. So I'm repeating this point, simply click here and select, click ascending or descending, in descending order. Okay, now you can see this sheet is available in descending order. In same way, so in multiple formats, in multiple sort cases, we can use it. For example, first by age, after that it will be in marks. Okay, so sorting we can perform. this aggregate aggregation. If you want to go for aggregation, split file, weight cases. Okay, so lots of features available. Now if we want to go for some particular data evaluation using plotting. Okay, so graphs, which type of graph we want to create? Bar chart, scatter plot, or histogram? Different types of plots we can create. Bar chart, x-axis. So you can see that percentage of cases, by which way, in which format we want to customize this particular graph. Okay, all cases we want to take. So we will take another scenario also. In x-axis, in category axis, we can take any. For example, this one. So this one is your bar chart, and on basis of x, in same way, bar chart on marks, percentage of cases or cumulative number of cases, percentage of cases. We want to take percentage. Okay, if we want to go for some histogram, for example, histogram, on which variable we want to create? On marks, display normal curve. Okay, now you can see this one is a normal distribution curve, and this histogram. So same features are available, same type of plotting is available in case of SPSS software. Now once it is available, now once we have plotted this, we want to use it in our research paper, we want to use it in our document. Okay, so you can see either we can print it, or I want to export. In which format we want to export it? I want to export it in, you can see, SPSS format, PDF format, HTML, or PNG format, or text format. You can see PDF, if I want to export it in PDF, or PNG format. Okay, what is the file name? Histogram. Save. And now you can see that this histogram is available. Yes, any query? One participant raising hands. Any query? If you have any query, you can unmute or you can write in chat. Up to this point, is it clear to all of you? In chat window, kindly confirm. Is it clear to all participants up to this point? Bar
Yes,
chart?
sir. Yes, sir.
Okay. So this is one case, and now we will see some cases, some evaluations. So you can explore it: scatter plot, histogram, and this one. So scatter plot. Okay, in y-axis, marks. Okay, in y-axis I want to put marks, and in x-axis age. We want to see this. So in descriptive statistics, in inferential statistics, in mathematical methods, there are different types of evaluations. Now very simple evaluation we will take. I want to simply write in chat. I will ask some questions in between the session. Kindly reply in chat. Some of you can reply so that at least I come to know how much you are aware. Okay, with these terms. Everybody aware with independent variables and dependent variables? What is independent variable? What is dependent variable? Is it clear to all participants? All of you aware with these terms?
Yes, Gaurav, they are aware. They are aware. I would request the participants to reply to this one. What is a dependent variable and what is independent variable? Yes, anyone who would like to answer, you can directly unmute.
Or participants can reply in chat
Yeah,
also.
yeah, yeah. Participants will need to reply. Sachin, yes.
Sir, a dependent variable is a variable which can be measured.
Okay, yes, sir. Actually, okay, I'm repeating that point very quickly. What is dependent? For example, on basis of one parameter, I want to predict another parameter. For example, on basis of x, I want to predict y. So y will be dependent on x. Very simple. Okay. On if I want to predict if there is any relationship between age and marks, I want to see whether marks are dependent on age factor or not. Okay, however, it is not feasible, it is not practical, but just for demonstration, okay, we can say that somebody's performance, whether somebody's semester wise performance is dependent on their future prospects or not. In that case it will be fine, but it is just for an example. I want to see if is there any relationship in this particular data, is there any relationship between age and marks or not. There are different types of tools. We call these methods as tools, statistical methods. I can use chi-square test, we can use t-test, z-test. I will come to those parts also in very simple way so that you can understand. But before going to z-test, t-test, we will cover it in very simple way. We can find out, we can predict relationship between two variables with scatter plot also. So I am showing you, I want to see is there any relationship between somebody's age or age, somebody's age and marks or not, whether marks are whether age is dependent, or somebody's marks can be can be predicted on basis of age or not. This is one parameter, or some other value I'm taking just for better understanding. For example, I'm taking bp level and somebody's health, or somebody's some particular parameter, positive or negative. Okay, covid status or disease. Okay, bp level we are taking numeric, 3 numeric, and disease. Now obviously it will be there will be a relationship. We want to find out whether somebody's bp level is directly related to disease or not. Okay, now I'm changing these values. I'm changing these values so that you will come to know. Okay, so clear variables, I have deleted all disease, bp, disease. Okay, and measure we are taking scale. Okay, this one also we can take as scale. Okay, or ordinal also it can be working. Now in excel I'm creating a data set. Random number 120 to 150. I'm creating some values, some random bp levels, and disease is random numbers 0 to 1, whether that person is having disease or not. Now I will paste it. Now I want to predict the relationship. I want to see is there any relationship between somebody's bp and disease or not. So in very simple way we will see it. We will go to graph. Relationships can be identified with scatter plot also. Okay, without going to t-test, z-test, or ANOVA. This is very simple approach. Scatter plot. In x-axis, we are taking BP level. In y-axis, we are taking disease. Okay. Now you can see this is scatter plot. Some dots are here at top, some dots are at bottom. It means there is no very strong relationship. I'm taking one more data set. I will show you how to import data. Okay, I'm having one realistic data relationship. This one is another data set. Okay, SAT score and GPA level. Okay, SAT. This one is one score, one somebody's score, and GPA level, GPA score. Now, this data is available in SAV format. This one is data view. I want to predict, I want to see the relationship, I want to establish a relationship between these two parameters, these two attributes. So what we will do, graphs, scatter plot. In y-axis, we will put GPA, and in x-axis, we want to put SAT, verbal and quantitative score. Okay, and we want to see, is there any direct relationship or not, is there any close relationship or not. Okay, so this particular graph is very much meaningful, and one point you should be very much clear that if your data is moving, so I'm opening magnifier so that I can zoom it. I'm opening magnifier, and with the magnifier I will show you this graph. So this one is my graph. Okay, one point we should be clear, if your data, if your plots, if your points are moving from lower left to top right, lower left from bottom left, this one is your bottom left. Okay, this one is your bottom left. Your points, your diversion is from bottom left to top right. It means there is a strong relationship between these two parameters, between these two attributes. Without taking any complex method, without taking any complex statistical method, we can directly see whether there is direct relationship or not. So you can see we are moving from bottom left to top right. Okay, this is very simple approach, very simple way to see a particular data set. Okay, in previous example you might have seen when I created one dummy data, this particular dummy data. In this particular dummy data, what was the major problem? Randomly we have created a particular data, we have created a particular file and we have pasted it. But what is output of random data? Obviously, if our data set is not good, in that case output will be abnormal, output will not be very effective. So that's why for research we have to work with benchmark data sets. Okay, in case of research methodology, in case of research based data analytics, we have to go for benchmark data sets. Now there is a new term, benchmark data set. How many of you are aware with this term? In chat, kindly confirm what is benchmark data set for research, and have you ever heard about this term or not? Benchmark data set. What is benchmarking of the data? So this particular data set is benchmark. To some extent we have used it. In chat window, kindly confirm, kindly write yes or no. If you don't know, you can you simply write no, so that I come to know that you are not aware and I will explain you. Because in research, when we go for data analytics, your data should be benchmark data set.
So standardized data that can be used to compare.
Yes, that standardized data. Okay, another description of benchmark data set means that particular data which is already tested. Okay, actually benchmark data sets which we use, these are generally secondary in nature. Actually, there are two types of data broadly. One is primary data set which we collect manually by questionnaires. Okay, and secondary data, for example, I have taken data from some medical lab. I am doing research on a COVID data set. So obviously I will not go to each and every hospital manually. I will not ask patients to fill that form. So what I will do, I will contact AIMS, I will contact PGI, I will contact Path Labs, different sources I will explore and I will ask the data set. So, okay, so we have to see whether that particular data set is benchmark or not. If we are taking data set from multiple hospitals and directly evaluating it in tool, in that case, our results will be very, very bad. Results may be abnormal. Okay, lots of sources available for benchmark data sets. So I'm showing you some particular portals. IEEE data port, very popular data set portal. Okay, this one is the portal for different types of data sets which you can take. For example, I want to go for evaluation of environmental conditions. I want to evaluate 5G network. Okay, what is performance of 5G network? It's Excel sheets I want to take. I want to work with cloud computing data set. I want to work with agriculture data set. So first major problem will come that from where I will take that particular data. So these data sets are available on these portals. So there are so many portals available. So if you want to take data set related to medical domain, for example, COVID-19, so these data sets are available. You can download it and you can evaluate. So for beginners, if we want to work with secondary data, but secondary data should not be haphazard data. It should be benchmark data. It should be pre-tested data. Okay, for example, you are from finance domain, so you want to explore that particular data related to finance and banking. So simply you can search and you will be able to explore it. Okay, computer vision, education and learning technologies. This one, industry based skill sets, data set of meter readings. So these data sets, all of these data sets are pre-tested by researchers. Another portal, data.gov.in. So if you want to take data related to government of India, related to ministries under government of India, for example, you want to take data related to Jan Dhan Yojana, you want to take data set related to farmers, related to agriculture, related to transport, airports, Manrega. Okay, so these data sets are available, are these data sets are distributed by government of India, different ministries, and we can analyze. So very good research papers we can write, very good analytics we can propose. Okay, so in labor and employment, in multiple domains, these data sets are available. In economy, okay, catalog, you can see. So, so you can see that import export data, data set of steels, data set of petroleum, year wise data available in Excel sheet format, in SAV format, which we can import in SPSS or PSPP, whatever tool you want to use. So you can see that category wise data, all of these links. So there is a complete list of data portals in multiple sectors, data.gov.in. Another portal, statista.com, for data sets that you can explore. Okay, IEEE data port, hundreds of sources available for free data sets related to multiple domains. Okay, so you can see social media data and very latest data. So social network from 2017 to 2028. It means predictive analysis data. Upcoming data, upcoming predictions are also available. So if you are involved in paper writing or research based content writing, you can use these data sets. So world's largest social media market, China. If I want to see its data, if I want to see its statistics, that is available. Okay, I can download and I can import that particular data in SPSS. Okay, so we our data set should be very correct. So graphs, histogram, scatter plot, and simply we can plot. If our diversion is from bottom left to top right, it means there is a strong relationship. Okay, now if we want to go for descriptive analysis, descriptive statistics. So up to now you might have gone through this particular part. Descriptive statistics, analyze. I want to go for descriptives. So different other methods available. For example, I want to go for compare means, one-way ANOVA, two-way ANOVA, t-test, z-test, linear regression, logistic regression, factor analysis. So we will start with this part. Okay, frequencies. For which parameter I want to go for frequency analysis? For GPA score. Okay, so GPA and SAT both I want to analyze. Mean, standard deviation, minima, maxima, and other parameters. So many other parameters available. Sum, median. Okay, and okay. It will give us a detailed report. So magnifier. I'm opening magnifier so that it can be zoomed. So you can see this one is the result. So GPA maximum, how many values are there? Total 15 records. Mean, standard deviation, and frequency analysis. And this one is frequency report, frequency analysis report from that particular software. In same way, if I want to go for descriptive analysis, descriptives, GPA score, GPA first year. Okay, this one. What is mean? How many total records are there? 15. And missing and means how many missing values are there? How many missing values are there? 0. Okay, what is a minimum? What is minimum value? And what is maximum value? Is this clear to all of you? Are you getting this content properly? Kindly confirm. Are you getting these contents properly or not? And up to this point, any query? If you have any query up to this point, you can ask. In descriptive analysis, so one more example I will take. So you can see that I'm having some data set, cross tab data set, cross tab data. If I want to use it, so few data sets I have already created for demonstrations. This one, gender, okay, and political party. We want to identify relationship of gender with political party or not. Data view. Okay, so we have put one for male and two for female. If I'm now I want to show you what is the uh, which type of measure we are taking. Both of these are nominal. Gender is nominal and political party is nominal, because the keyword political party is not having any inherent meaning. Okay, if I'm saying X political party, Y political party, there is no value of X internally. There is no value of Y internally. If male and female is there, these are nominal parameters. Okay, we can't use gender, political party, state, city as scale or ordinal. Okay, so these are the values. So male from which political party, this one, female from this political party. So two political party, this is also this is again another benchmark data set. Two political parties, Democratic and Republican. So just for demonstration, we are taking it. We are not taking any political party, Indian political party in this particular data set to avoid any particular biasing, transparency, or favoritism. Okay, so that's why two names we have taken, Democrat and Republican, to be very very generic, and male female. Now, if you want to go for cross tab, okay, descriptive statistics cross tabs, we want to see a relationship of gender with political parties. Statistics, okay, which method we want to apply. So many statistical methods are available. Okay, so you can see that, and this one, I'm zooming it, and now we will be able to see it. So this one is relationship. Okay, male male in favor of Republican, Democrat party 5, Republican this. What is percentage? This one is percentage level. Pearson, this one is your direct relationship values. Total 30 records are there, and if you want to identify relationship, chi-square relationship, so I will cover this part also. Are you already aware with hypothesis testing or not? Kindly confirm. Are you aware with this particular term? What is hypothesis testing? In chat window, kindly confirm.
Yeah,
What is
Gaurav, to some extent they know what is hypothesis, but you can repeat if you want.
Okay. Okay, dear participants, now I am repeating this part, this particular point. This is very, very important in research, and you will be able to understand it very easily. Okay, this is my notepad. In this notepad, I will explain what is hypothesis very quickly. I will cover, and after that, I will cover it in. I will explain it in as PSPP software. Okay, because we should be clear with the concept. Hypothesis means, in very simple way, in very layman's way, assumption. When we start any research, we start with some assumption. Technically, we call it as hypothesis. Broadly, there are two types of hypothesis. One is null hypothesis, that is written as H naught. Okay, and second is alternate hypothesis. Okay, alternate hypothesis, HA, or whatever notation you want to give. So hypothesis, two hypotheses. Now, for example, so I'm taking very simple example of medical data. We have, for example, government or some particular company released a particular vaccine. Okay, testing of a vaccine. In case of COVID also you might have seen. Okay, this one is our case study. Testing of a vaccine on specific BP level patients. Now we want to see, for example, this is my data set. Somebody's BP level is 125, and that particular person was was found positive. Okay, or that particular person was treated okay with that particular vaccine. Another 132 and 0. Okay, in same way 129 and 1. In this way we want to test whether a particular vaccine will be applicable or will be effective on specific patients or not, on specific persons or not. In that case, what will be our null hypothesis? One point we should be clear, that null hypothesis means negation. We assume, without testing, we assume that there is, we will write null hypothesis in this way: there is no impact of X medicine, X vaccine, whatever vaccine we have given on the persons, okay, or on the patients. This is our null hypothesis, and there is major impact. So two hypotheses we have written. One is we assume that nothing will happen, and second, there is major. Another scenario we can take very quickly. For example, this example I am taking related to education domain. It will be very easy to understand. For example, some particular person got these marks before coaching, before training. These are the marks of a particular student. These are marks of the students before training, and after training, this one is the diversion. Now these are the marks obtained by particular student or set of students before training and after training. Now we want to see, is there any impact of training or not? So what will be the null hypothesis? There is no impact of training on students' performance. This is null hypothesis, and there is major impact. So in this way we write null hypothesis and alternate hypothesis. Now we have to prove it. We have to prove means we will see, is there any relationship between these two sets or not. So as far as proving is concerned, we will not do summation. Okay, you can somebody can say that, okay, we will go for summation, okay, sum of these numbers and sum of these numbers, but we should not take directly summation. We have to perform test. We have to perform chi-square test. We have to perform t-test, z-test. Whatever test we want to perform, we have to see. And whatever output, there is a particular value that is known as significance value. Significance value. Okay. So we have to see, that is known as p-value. When we perform some statistical test, for example, I am performing some statistical test on this data, p-value is obtained. This p-value is compared, this particular p-value, this particular compared, okay, p-value is compared. So whatever significance value, for example, in this particular case, we are having a significance value, okay, which significance value we are getting? 0.037, 0.033. So these values we are getting. We have to compare these values. So I am coming to that. So we will, so I'm closing this and I will explain it. separately because we have enabled the magnifier and now it is okay. Okay, so whatever p value, so what we will do, a particular significance value and p value, these are analyzed. So for example, one value we are getting here 0.02, significance value we are getting 0.02, it is compared with 0.05. If significance value, if this particular value is less than 0.05, obviously 0.02 is less than 0.05, in that case your null hypothesis will be rejected, will be rejected. So otherwise null hypothesis will be accepted. I'm repeating this point. For example, after performing some test, whether you are performing t-test, z-test, ANOVA, it depends on the data set, it depends on your objective. We have obtained p-value 0.001 or 0.001. This particular value is less than 0.05. This is a fixed value. It is fixed value, global value we generally take in statistics. It is compared with 0.05. If it is less than 0.05, in that case null hypothesis is rejected. It means there is major impact of training on student performance. If we are getting this type of value, for example I achieved 0.09, it is greater than 0.05, in that case null hypothesis will be accepted, and in that case we will conclude that there is no impact of training on student performance. Are you getting this or not? To some extent, are you understanding this point or not? Kindly confirm. What is hypothesis, how to test, how to compare it? So okay, anyway, I will show you, I will demonstrate it in this part, in PSPP. This is PSPP. Okay, now I'm taking one data. This one is my data set. Now see this very carefully. I will explain t-test. It is very simple test, and you will be able to understand it very easily. What is t-test? Okay, there are certain conditions, there are certain guidelines related to t-test. I will explain that part also. This is the data. This one is my PSPP software pre-training. Okay, this one is pre-training and post-training. Two variables. How many marks are achieved by a particular by student? Pre-training 10, 20, 10, 20, 43. After training, these are the marks. For example, I am taking this one 98. I am taking post-training 78. These are the marks obtained by a student. Is this visible to all of you? Kindly write. I am explaining t-test for implementations. Is this visible and clear to all participants? This sheet I have in cascading way so that I can read your message also. Now see this very carefully. I want to perform t-test. Okay. First of all, we should be very much clear because there may be confusion. There may be a particular question. Okay, why we are implementing t-test? Why not we are implementing ANOVA? Why not we are implementing factor analysis? If we are having two variables, paired variables or couple variables, these are couple variables, pre-training and post-training. These are paired on same parameter, on same type of attribute, on same type of data. We are having two attributes, two values. It means pairing is there. In that case, we use either t-test or z-test. I'm repeating this point. For example, I'm having this particular data. Okay, before vaccine BP level, What is BP level before vaccine? Before vaccine, BP level of some patients was this. Okay, this is the set of BP level of before vaccine, before taking vaccine. After taking vaccine, what is BP level? BP level of patients moved to this. Okay, this one is set of BP level of patients or persons. Before giving medicine, this was the BP level. After giving medicine, this is BP level. Now we want to identify if there any relationship of vaccine with BP level or not. Is there any impact of vaccine on BP status or not, blood pressure? Okay, so null hypothesis will be there. There is no impact of vaccine on BP level, and obviously its alternate will be there will be major. Okay, there is major impact. Now we have to prove either we can use T test or we can use jet test. Why? Because both of these are BP. This is also BP. This is also BP. This is paired test. Pairing. Now where we have to use T test? See this very carefully. What I am typing here. If data is less than 30, if data records, if records are less than 30, then T test, else jet test. If my records, for example, in this case we are having 4 cases, 1 2 3 4, 4 cases, 4 is less than 30, we cannot use jet test. If we are having 29 cases, 29 records, 28 records, less than 30 records, we should use t-test. If we are having large data, thousands data, millions of data, billions of records, in that case we will use jet test. Is this clear to all of you? Are you getting this point? If number of records are less than 30, then T test. So you can remember it with alphabetically. Okay, T comes before Z. Okay, T in alphabets, T is coming before Z. Okay, because sometimes we may be confused. Okay, whether 30 is for Z or T. So what we can do, what we can do, if T is alphabetically coming before Z, or you can remember it with T for 30. Okay, T, first letter of 30 is T. So T test will be implemented. Otherwise, if we are having large data means Z, last alphabet in your in all the alphabets. Now this particular data we want to test with t-test. So this is my PSPP. I will go for analyze, compare means, paired sample t-test. It will ask which are two samples, pre-training, variable one, post-training, this one. You can see pre-training, post-training. We have put these two. Okay. Now you can see this one is the result. I want to export it. Export this result in on desktop in HTML format or in any format I can put. For example, I am putting it in HTML format. I am saving this output. Save. I will show you its interpretation. Okay, this one. So this is the result of t-test. Is this visible to all of you? We will go for its interpretation. What is meaning of these tables? T significance value 0.04. 0.04, you can see paired sample t-test 0.04. It is less than 0.05. It means null hypothesis is rejected. Null hypothesis rejected means there is major impact. Now another, for example, another data set we can take, pre-vaccine. post vaccine. Okay, before taking vaccine, what was the BP level? 120, 122, 122, 128, 129, 125. These are BP level before taking vaccine. After taking vaccine, this is the BP level of persons who have taken the vaccine. Somebody's BP level moved beyond limit. Okay. Now we want to see, is there any relationship of vaccine on somebody's BP level or not? Analyze. Compare means paired sample T test. Pre-vaccine, post-vaccine. Okay. Now you can see 0.4 and 0.9. 0.4 and 0.9. 0.4 and 0.9 both are greater than 0.05. It means null hypothesis is not rejected. Null hypothesis is accepted. Null hypothesis accepted means there is no impact of vaccine on somebody's BP level. Are you understanding this point? Kindly confirm. Are you getting it or not? In chat window, kindly confirm, are you getting this particular concept or not? Okay, so for example, some more records I want to add. 121 so I'm changing it. So somebody's BP was low, somebody's BP was low before taking vaccine. Okay, and after taking vaccine, what is the impact? So I'm changing this data to this way. Okay, after taking vaccine, this one is the data, this one is the BP level. Now I want to see, so somebody's BP moved to 150, pre-vaccine, post-vaccine. Some more records we can insert, 98 and 140. Now we want to see with this particular data, analyze, compare means, paired sample T test. Okay. Now 0.012, 0.012 significance value, 0.012 is less than 0.05, 0.012 less than 0.05. It means null hypothesis is accepted. Null hypothesis null hypothesis rejected. Null hypothesis rejected means there is major impact of vaccine on BP level. Is this clear to all participants? Kindly confirm. Okay, so very simple thumb rule. If records are less than 30, then apply T test. Otherwise, apply Z test. If you have any query, you can ask up to this point. Any question? Okay, we want to put some particular, we want to see it in form of graphs. Okay, and scatter plot. We want to see its relationship. So in this way. So dear participants, if you have any query, you can ask. Whatever we have covered in this session, if you have any query, you can unmute or you can write in chat. Session is open for your queries, for your doubts.